I think we can start slowly to get into this session, the last one for today. And I would like to welcome you very much, despite some strong competition in the other parallel sessions. We are very glad that you're here, and we hope that we can present you some interesting information regarding to the data that is produced by the Human Planet Initiative. You know that the topic of this entire symposium is strengthening inclusive partnerships in the GEO work program. And I think this is exactly what we want to achieve with this session, because we think we in the Human Planet Initiative have something on offer, and would like to present that to you, and then see if we can work together with the information that you are providing, maybe in other initiatives, or you also want to join the Human Planet Initiative. That is all very welcome. And seeing that we are a rather small group of people, I think we are small enough so that you can come in immediately. If you have questions, you can raise your hand, and we can then pick up your questions. But before we do this, I would like to introduce to you today's participants, today's panelists. And in the first place, there's also a parallel session too, which is my colleague Pietro Florio, who is managing the session as the host. So thank you very much for that. And then we have three speakers. We have Bob Chen. Bob is probably everybody knows him here. Bob is the co-lead of the Human Planet Initiative, but he's also co-chair of the SDSN Thematic Research Network on Data and Statistics Trends. He is director of CSIN at the Earth Institute of Columbia University, and manager of NASA Socioeconomic Data and Application Center, CEDA. So a lot of heads and very important data contributions from your side, and I'm looking forward to hearing from you. Then we have Nalizani Mudau from the South African National Space Agency. Nale is a remote sensing scientist. She's working a lot also on the analysis of human settlements, and uses that information a lot in the context of the Sustainable Development Goals. And she is here today to represent the EO4SDG initiative, with which the Human Planet Initiative is closely collaborating. And then we have Daniele Ehrlich. He's working at the European Commission Joint Research Center in the Disaster Risk Management Unit in the Global Human Settlement Layer team. And he has also many years of experience in using Earth observation data for many application domains, but with a strong focus on disaster risk management. And my name is Thomas Kemper. I'm leading the Global Human Settlement Layer project at the Joint Research Center of the European Commission in Northern Italy, and I'm trying to moderate this session. So welcome again. This session really tries to provide to you an overview of all the information that is provided by the Human Planet Initiative, and give already some indications on how this information can be used by combining it with other data sets. And I think without further ado, I would ask Bob to present his slides on population settlements and infrastructure data for GEO applications in climate disasters and sustainable development.
Great, thanks Thomas for the intro, and glad to have a chance to talk to everyone. I'm sorry we're not all gathered in Geneva for the symposium, but at least we want to keep up the momentum and interact with other parts of GEO and other stakeholders. So as
Bob, sorry to interrupt you, because Pietro has probably still the window on the right-hand side of his screen with the participants. If you minimize that, Pietro, then we would see the full slides of Bob.
right, it's blocked.
Yes,
There we
perfect.
go.
Thank you.
You can go to the next slide. That was just the title. Next slide. So I thought I'd just give a little context. Obviously, we know world population has increased a lot. We still looks like another billion or more by 2040. And I don't think I need to repeat for you that knowing where people live is really critical. Next. But, you know, population isn't even. There are even some parts of the world that are slightly depopulating. So population's heterogeneous. Next. And we know climate change is heterogeneous. This is from the IPCC special report, and it's actually historical data on experience of different temperature changes. And so looking ahead, it's likely to be equally heterogeneous. Next. And of course, for the disasters and hazards, we know hazards themselves are very spatially heterogeneous. They're but also the way in which people are affected, their ability to protect from extremes and to resist or rebound from stress is highly variable. And you can see that in the historical disaster data, among other things. Next. So, you know, our basic premise, of course, is that there are certain parts of the planet that humans have greatly affected, and having you know, detailed data and using Earth observations to improve that data is really essential. And this has been recognized in a lot of places. Some of you are probably familiar with the UN Committee of Experts on Global Geospatial Information Management. A couple of years ago, they came up with a list of 14 fundamental themes, of which the three highlighted here: population, settlements, and buildings, and infrastructure are what we're focused on in Human Planet, but you know, also ties in with names and functional areas and other layers. Next. So, you know, again, I'm sure you're all familiar with different applications. I just pulled a few from the literature that I thought were illustrative. The Lancet Commission came out with a report at the end of last year, or I guess it was officially published early this year, looking at different climate change health issues. You know, that itself was sobering, but from the viewpoint of the data needs of the public health community, they were using gridded population data in quite a few different areas, at least 4 different citations, uses of data in the analysis, because obviously, you know, the health impacts relate specifically to where people live. Next.
Yeah. Bob, sorry to interrupt you. It seems that David Borges has problems with the slide advancement. So I would ask Pietro to unshare to stop the presentation and restart it at the same position, to see that if that might help to
Okay.
allow him also to follow.
Right.
Thank you.
Well, I hope that fixes it. Next. Just as other examples, it happened last September. Science magazine published 2 different papers, one related to eliminating plastic pollution. And there have been quite a few papers that just use population and proximity to, coasts or roads or that sort of thing. That's a typical application. Another one was kind of interesting because they were looking at seismic data to assess the impacts of COVID lockdowns and, notice detection. And part of the analysis included separating out urban and rural data and population density. I think they used the JRC data as well as our population data set. So, these are sustainable development and disaster and climate change applications next that you see in the scientific literature. In some cases, they get translated into decision support systems and policy. For example, there are population data sets built into Global Forest Watch, which I'm sure many of you are familiar with, next. And in the Partners for Resilience and Preparedness, a climate change decision support tool that the World Resources Institute and others have put together. So these are just examples of the kind of online mapping tools that utilize population to provide, not just visualization, but the ability for people to understand, either how humans might be affecting the environment or being impacted by environmental change, pollution, or whatever. Next. Of course, one of the issues that Human Plan is trying to address is that there's not just one way of depicting and modeling population at high resolution. Of course, all the data sets pretty much start with census data, and census allows you to, of course, go down to some hopefully small administrative area that varies a lot by country. And so, the basic is just taking census data and gridding it, but there's been a proliferation of data sets because people have realized, of course, that people aren't spread evenly within a particular administrative area. They, if you can see their buildings, or if you can build a model that projects their location near roads or based on other factors, you can get a better sense of population distribution. So over the past couple decades, quite a few different data sets have developed by different groups, including commercial entities, as well as different government and academic groups. Next. Oh, and as you can see, they vary quite a bit in how well they do in different areas, whether, some are better, it appears, in urban areas or versus rural. Different parts of the world may be done better because, the data that they're using is more robust or more recent. This happens to be a graph from a review paper that was produced by our group, comparing the different data sets, looking at the assumptions, the inputs, and so forth. Because the question of which data is best for which purpose is important, depending on what the use is. Next. And we realize that it's not just the scientific community that wants to understand the differences in the data. There are many applied users, and in particular, we've been trying to work with the sustainable development community to understand, where population data is important to the different indicators in the 17 goals, and which data sets might be the most appropriate for those indicators. If you're trying to assess the number of people that have access to rural roads, you don't want to use a data set that modeled the population distribution based on the existence of roads. So trying to think about appropriate and fitness for use, and match data and understand what's most useful in developing countries, or where some of the data sets do well or poorly at mapping population is important. Working with trends, we developed a more general publication for people to use that hopefully gives them some sense of what the trade-offs are. Next. And as part of the overall effort, we've developed this site called the popgrid.org, which pulls a lot of the different data sets together and the data on them, and allows this community to communicate and collaborate more than they have in the past. Next. And one of the things you can do is actually go on and find a tool that lets you pick from actually the 6 main different data sets, but also different points in time, and just visually compare them, and actually next do a comparison and find out for any particular area how varied the different data estimates are for that area. So this gives people a better idea of a little bit of idea of what the variability uncertainty is in the population data sets. Next. But of course, there's a lot, we'd like to do more validation, have a better idea. Actually, a paper that's literally just came out in the last day or two, working with a group called Idea Maps, has been looking in detail at slums, where it looks like most of the population, global scale population data sets, greatly underestimate the number of people in slums based on some ground-based data collection. But this is still kind of a research area where we're trying to get a better handle on what these differences are. Next. And of course, we're not just interested in population counts. There has been work on getting better age and sex and urban rural structure. But if we're thinking about these engagement areas, we need to know, are they industrial? Are they residential? Are the buildings well maintained and fragile? Are they, how do they tie in with the critical infrastructure and so forth? We want to tie in with those other fundamental geospatial layers. We want to do more validation and uncertainty so we can give people practical information about whether it's 100,000 people there, or plus or minus X% or not. We can't do that yet. And trying to engage with other parts of GEO and with stakeholders to kind of understand what their needs are. Next. Oh, I think that's pretty much it. Yeah. So happy to take questions, and I know Daniela and Nale will probably go into some of these things deeper. Thanks.
Yeah, thank you, Bob. Very, very nice presentation. Again, we mentioned earlier, if you have questions, just raise your hands or put them also in the chat if you prefer to. What we would be interested in, of course, is from which part of GEO are you coming? Which is your initiative, your community you are coming from? We will have also maybe later after the 3 presentations some more time for discussion. So now I think we could have some questions directly related to Bob. Maybe one quick one I have already, Bob. You mentioned the different data sets and the PopGrid tools that should help people to select the right population grid. Is there a very good recommendation on how do I select the best data set for my application, or is it really testing all the different ones?
Well, there is kind of guidance in that publication I mentioned. It's not, everybody has a different trade-off in terms of, not just the spatial resolution, but the time, the time scale of their interest. Some data sets go back a few decades, some don't. Some are, again, have different factors that went into the estimates. So there's no simple answer. And what we try to do is give people examples of where others have used things successfully, and some, just guidance on what factors to think about when you're making a decision. And then the tool does let you play around with the different data sets. It doesn't replace, someone with GIS expertise and doing an in-depth analysis, but it hopefully will help people get a handle on, what data set might make the most sense for their region or their application.
Thank you, Bob. I don't see new questions in the chat. So I would propose we move on to the presentation of Daniele Ehrlich, who will present the global human settlement layer's point of view of data availability and usage. So Daniele, the floor is yours.
Thank you, Thomas. Can you hear me? Yes. Yeah. So Pietro, could you put up the slide, please? So just since the topic of this conference is strengthening inclusive partnership, we felt we wanted to tell you about the global human settlement layers. Also because those 3 layers now are part of the knowledge package in the GEO Knowledge Hub that will be available soon. So this presentation will just briefly summarize what those 3 layers are, and most importantly, what their uses are. And in order for you to get inspired possibly to work with us and increase the range of applications for which this data are used. So please, Peter, next. So let me start with the first layer. We call it the Global Human Settlement Build, because it represents the built environment globally. The dataset is produced using archive data, all open data, and for the first 4 epochs, it's Landsat imagery. So we use all the Landsat image archive to produce 4 slots for 4 epochs in time they built up. So 75, 90, 2000, and 2015. And we are completing now the new updates for 2000 based on Sentinel data. And from them on, they will be continuing a combination of the 2 sensors. So it is produced by using, of course, artificial intelligence. And the main important thing is that what we are trying to map is the presence of building globally. You can see from that when you combine the different dates, you are able to identify and measure the spatial growth of the city, which is an invaluable information, especially now, because in the last 30 years, the growth of built up has been incredible. Yesterday, in one of the opening speeches, they said that between 1990 and 2020, the equivalent of the size of India, I think, has been increased in built up, has compared to built up. So just to say that we use this for a number of for a number of applications. The second layer is actually, next slide, please. The next slide is actually about population, and which was referred to before from a presentation for the previous speaker. So we are producing this layer in a collaboration with Season. And what is special about this layer, or is different from other spatial grids on population, is that we are using the built up to disaggregate the population. And we feel that the built up, and this is a linear disaggregation, and we feel this is a robust method because you can always measure built up from satellite imagery over time. And that allows also to make consistent and possible the comparison of population over time. We use population spatial grid in a number of applications, including disaster alert system, and has been especially extremely used in crisis management in many phases of the crisis management cycle. I would like then to go to the next layer, which is we call it the global human settlement model. Well, this layer has been produced in close collaboration and consultation with the users. In this case, our international NGOs, UN agency that have requested, certain set and have worked with us to produce a standardized way of measuring cities and settlements. Among the agencies that have worked with us is the European Commission, which is, of course, our organization, but also OECD, FAO, and a number. And UN Habitat, for example, is also part of it. What this layer allows us to do is first to identify cities across the globe in a consistent manner. And once you are able to identify the boundaries of the city, you are also you can measure population within a number of attributes within the city outlines, including population changes, as shown in the figure above. And it has been extremely useful also to being able to measure urbanization rates across countries in a standardized way, as all countries use different criteria for measuring urbanization. So we feel that these three layers are not only three layers, but the three layers have been co-produced, and the combination of the three are more the sum, are just more than just the sum of the three, because they are consistent and can be used together. And for this reason, we wanted now to present you a number of applications for which this data have been used. Next slide. So the Human Planet Initiative produces every year, has been producing every year one atlas of the human planet. And the one of 2020 has collected a number of applications that use these GHS layers. And I'm presenting now in a few slides the most relevant, I think, for you to convince about the usefulness of the data. In addition, just recently we have been written a review paper that reviews about 55 policy and scientific documents that use one or the three GHS layers. And this application measure the impact of society on the different physical systems, ecosystem, biodiversity, atmosphere, and so on, as well as the impact of the physical system, the weather, the climate on human societies. But now the next slides, I will just present a few examples of the application from the Human Atlas. First of all, we feel that the GHS layers are used when we need to compare population built up across regions or globally. For example, we have been working with the GEO mountains to be able, and we are working actually still with GEO mountains to measure population across mountainous areas of the world. This slide is just a preliminary study conducted in 2020. And now we are continuing this work with GEO mountains to understand where population is located in mountains, where it grows, and the impact of disasters and so on, in a number of applications. A second area, also regional, is the Arctic. And here we see a polar view of the Arctic Circle with the different countries, Greenland, Russia, United States, and so on. And we have been measuring the changes in population and settlements and urbanization within this area. We have not connected with the geo-Arctic component of GEO, but that could be a way to link. Next slide. But I would like just to make sure that that everybody knows that the layers were originally produced in order to address the crisis management at the different phases of the crisis management cycle, from alerts to risks and so on. And mostly the GS built and the GS population is being used as typically as exposure, but when combined with other variables also to measure vulnerability. For example, now the layers are used for the United Nations Convention on Combat Desertification drought toolkit, where population is combined with livestock and cropland to issue alerts on drought risk. Or with the Global Wildfire Information System, another GEO project, where the built up is being used to exclude, together with the water layers, the areas for where fire cannot occur in order to reduce false alarms. Or is used in the global flood alert system, where the outlines of the flood extent are superimposed on the population grid, in our case, in this case, the GS population grid, in order to estimate the amount of people affected. Next slide. But of course, these are just an example of GEO projects that have been using these layers in crisis management. The Copernicus service of the European Commission is using extensively also these layers in crisis management. And I would like just to also to mention that the Paris Agreement, the two components of the Paris Agreement, how they use emissions. In this case, next slide, one click more. Yeah, thank you. In this case, basically, the emission data, the global emission database have been crossed with the settlement model that identifies cities, towns, suburbs, villages, dispersed, and rural areas, and have been able to estimate the amount of emissions from CO2, nitrous oxides, or sulfur oxides, and so on, at the settlement level. And these are the statistics. That is an example of emission measurement for the Paris Agreement. Another application for the Paris Agreement, next slide please, is the climate, the possible impact on climate and sea level rise. Here, a study from Susan, from Columbia University, Deborah Bock, has identified all the low elevated coastal areas and the settlement types that fall within these low elevated coastal areas. And with the built up layer, you can measure the expansion of built up over time and thus the increase in exposure over time in this very high risk area. And on that, possibly, you can model also possible future sea level rise events. Next, I could not omit the indicators and the sustainable development indicators. And this slide is just to tell that, of course, the built up helps to understand the spatial growth of city across the globe. And that's something that, for example, even the OECD is doing extensively. And here we have a report issued last year. But most importantly, I wanted to say that the three layers are the three ingredients, indispensable ingredients, to be able to use some SDGs indicators. For example, 11.3.1. In that case, you both need the change in time of the built up, the change in population in time, and a definition of a city outline. So if you don't have those ingredients, you're not able to measure the indicators. Unfortunately, the three GHS layers provide that opportunity. Other indicators can be provided also, and I show here just another one, the amount of green spaces in cities. Next, yeah, finally, I wanted with this slide, I wanted just to summarize a little bit the outreach of the human planet towards the GEO community. And I here map just established links, the potential links, and the possible links. And of course, crisis management GEO projects are the ones that are already in part taking up in one way or the other our GHS layers. But of course, we have the regional part. Possible in the future, we'll be able to mention energy, those that address energy, and ecosystem impact. We have heard that ecosystem is an important thing. We enter in the decade of ecosystem restoration, a new UN agency. And finally, and this introduces maybe the next speaker, is that the GEO Human Planet Initiative is very active and collaborates with EO for SDGs in order to help in producing capacity building. And with that, I think this is my last slide, please. Next one, yes. So on the top, you have the Human Planet Initiative that provides some of the results of the last 5 years. And if you have any questions, I'm happy to answer the questions. Thank you.
Thank you, Daniele. Are there any questions directly to Daniele's presentation? In the chat, I don't see anything. Also, in view of time, I would propose that we then move immediately to the presentation of Nale on the EO for SDG toolkit and how the Human Planet Initiative contributed to that. And after that, we can take questions also from the floor, from the participants. Nale, I hand over to you. Pietro, please put up the slides of Nale.
Thank you, Chair. Today marks 118 days since the launch of the first Earth Observation Toolkit for the SDGs. And I'll be sharing more about the toolkit. My name is Ngarezani Mudau. I'm from the South African National Space Agency, and I'm representing the EO for SDG an initiative that is looking at the development of EO toolkit for sustainable cities and human settlements. Next, please. You all agree with me that Earth observation data and geospatial data play an important role in planning, monitoring of targets, and also in tracking progress made towards achieving the Sustainable Development Goals. The Earth Observation Toolkit for Sustainable Cities and Human Settlements its objective is to support knowledge sharing and also promote collaboration between decision makers and planners and end users on issues relating to monitoring of the indicators, focusing mainly on the SDG 11 indicators, and also looking at monitoring the implementation of the new urban agenda. So the toolkit is also was developed in collaboration with the UN Habitat, who is the custodian of the SDG 11 indicators, and also an agency that is looking at the implementation and monitoring of the new urban agenda. Next slide. So we are focusing on 4 thematic areas, which are all linked to the SDG targets, and of course, SDG 11 in particular, looking at affordable housing, which is focusing on target 11.1, open spaces, which is focusing on 11.7, target 11.7, urbanization, which is 11.3, public transport, which is 11.2. So the objective of the toolkit is to provide the users, decision makers, with a platform where they will be able to access data, EO data that they require, also the available tools, and also have access to some of the case studies which have been conducted across the globe on the use of Earth observation to support the SDGs. Next slide, please. So in terms of the data, the toolkit showcases open and freely available data sets, which vary in terms of coverage. Some cover few countries, and many of the data sets cover the whole globe. So users are able to go in and search for the data of interest. Also the period in terms of when the data was created. They can also filter the data sets using indicators from housing, transport, urbanization, open spaces. They can also filter the data using the format of the data, resolution, amongst other filters. So for example, in terms of the data that we have Microsoft building footprint data, which covers USA, Canada, Uganda, and Tanzania. And also we have other data sets that are looking at impervious surfaces, which can also differ in terms of coverage. Some are covering some continents and some cover the whole globe. So we currently have about 27 data sets which are loaded in the toolkit. Accompanying the data sets are also documentation in terms of how the data was created, the user guides, and also link to download the data. The data sets also include the GHS, the global human settlement build-up layer as presented by Danielle, which is used mainly for the development of the urbanization indicators, such as 1131. But otherwise, some of the data sets or the links that we have will also include the scripts, if available, to produce such data sets, allowing the users then to go produce their local data using the tools that are already developed in terms of tools to generate the data. Next slide, please. In terms of the tools, we have loaded about 9 tools. So the tools that we have on the toolkit are to support either the visualization of the data sets or also to generate particular indicators. For example, you have the degree of urbanization grid, which will show you the classification of human settlements from cities, urban to rural areas, which can then be used in terms of quantifying some of the indicators to provide more useful information that can also contribute towards planning of some of the development solutions. So you also have other tools like the global man-made impervious surface and human build-up and settlement extent data visualization tools, which allows the users then to go in and see and visualize the man-made features in terms of impervious surfaces, the extent of build-up areas, to help in the development of indicators for open spaces, which is 11.7. In addition to such tools, we also have other viewers that demonstrate the applications of some of the data sets that we have to help in decision making For example, if we're looking at the global pandemic that we are dealing with, so we also showcase some of those tools so that the users can also go in and get information that they require to support decision making. So as with the data, also with the tools, the users can also go in and download if the tool is available for download, or else then they get access to the link to visualize the data or the tool. Next slide, please. So in addition to the data and tools, we are also showcasing case studies on the use of Earth observation data and other geospatial data, statistical data, and demographic data to support the development of indicators, and also in support of projects that are aimed at promoting sustainable development. So we currently have loaded on the site 11 case studies across the globe, and users who are able to go in and read more about the case studies and learn more about the data sets that we use, tools that we used, and then they can also go onto the map and search for those case studies per area or region of interest. So the case studies all currently cover the 4 thematic areas, which are looking at urbanization, housing, transport, and open spaces. Next slide, please. So in addition to the data tools use cases, because the aim of the toolkit is also to promote collaboration, knowledge sharing across the globe. So users are also able to go in and search for experts and city or country representatives, or those who contributed through data, case studies, or tools. Their users are able to go in and get their contact details, and then depending on their interest, and they can then start working together or share more information. Next slide, please. So to access the toolkit, you go to eotoolkit.unhabitat.org. So in addition to tools to access to visualize it, in addition to access to the data and tools and use cases, users will also be able to learn more in terms of some of the case studies or data or production of data or indices or development of the indicators. So if there are any additional learning materials on a particular thematic area, users will be able to get more information about that. But in addition, those who would like to contribute will also get an opportunity to also share what they have, whether it's data, tools, or even if they're offering their skills, they'll be able to share that information with the team. I think this should be the last slide. Thank you for your participation, for your attention. Otherwise, I was representing a big team of space agencies and organizations who have contributed to this toolkit, led by Aji, Dr. Kavada. So there is her email address. You are more than welcome to contact myself or her. Thank you for your participation and also interest to this presentation.
Thank you, Nales. Thanks a lot for this overview of the GEO for ICT Toolkit, which is, I think, really a very good example of collaboration within the GEO work program, because all of the speakers actually today have been contributing to the GEO for SDG toolkit. And in a way, I have the feeling it's already hard to separate between the EO for SDG initiative and the Human Planet initiative, because there are so many overlaps. And I think this is really also the aim of GEO as a whole, that we don't work in our silos on Human Planet and EO for SDG, but reach out to others and create new knowledge. But let me now reach out to you and ask if you have specific questions to the presenters. Raise your hands or just come in as the questions come up to you. I will not wait the 5 minutes until time is over and start shooting questions myself. Maybe starting with Bob. We've seen there's already a lot of information out there, also global data sets. But from your experience, are there still also gaps in areas where we still have too little information at a global level?
Sure. I mean, there are regions, particularly rural areas, where there are only a couple of the groups that have spent time trying to do more detailed modeling. And the same goes for regions like slums that I mentioned. And, there are going to be issues related to things like temporary settlements or migrating people and so forth that we don't capture as well. I mean, I didn't go into it, but certainly in the Sustainable Development Agenda, there is this idea of leaving no one behind. But when it's very small populations scattered across the world, it becomes really challenging to get global scale data that can get down to the scale of a few meters and accurately count people and characterize them.
Thank you, Bob. Daniele, you started working with the mountain community, so combining the information about mountains with population data coming from our side. What would be for you the low-hanging fruits of working with other GEO initiatives? Where do you see big potential to collaborate and come up with new findings? Like you presented also the work with the Arctic to really show where people are going away from Arctic areas for whatever reasons.
I was just thinking, even GeoCoast. I mean, the impact on the coast of societies is quite important. And I have made my calculation of how many people live within 50 kilometers from the coast and how that has changed over time. I would love to talk to GeoCoast and see if my quick analysis could be of use, for example. But there are all applications for which a cross-boundary will be, I feel our data can be relevant. And since I have Paul Henshaw here from the GEM, I would also say that I would love to see, the built-up combined with more typology information on buildings across the globe, to be able to better characterize vulnerability to seismic hazard risk, for example. I have really many ideas, but I'm happy to discuss, and I just provided you a few.
Mm-hmm. Thank you.
Can I step in to say something there? Thank you for that, Daniele. I wanted to ask if there's been any effort to involve groups that are boots on the ground, like the humanitarian OpenStreetMap team, to combine the Earth observation satellite approach with the very local knowledge, so as to try and get the best of both worlds. I know that so we've worked with the HOT team a couple of times. I know they're not the only groups that do that, but I think in particular for characterizing buildings and the vulnerability of buildings, if you don't have that knowledge or so it looks on the outside, it looks maybe that's a wooden building, or it looks like it's a masonry building, but if you don't know what the traditions are and the times that the building traditions change, the building laws change, then that's information that's very difficult to get without a local presence. So I wondered if any of you have any comments on that.
Daniele, you want to come in? If not, I have a little bit of ideas, because
Go ahead.
let's say our main focus is really to provide global information, and hence we need to be somewhat general. And it was quite difficult to come up with good quality global information in the first place. But I think now we have reached that. So there's not only the GHSL data, there's many other global data sets also on built-up area, etc. But I think what you are now referring to is the next level. So the next generation of global information on buildings needs to go beyond just saying there is a building, yes or no. So we need to come up with more information. I'm afraid we will not immediately get to the level that you would love to have for earthquake information, but already information about the height, for example, which is mostly absent at the global scale, or the usage of the buildings. That is something where also our team is currently working on, so that we can come up at least with information about residential and non-residential buildings. Then we need to refine this more and more. And I fully agree that initiatives like OpenStreetMap are really the way to go, because they collect this ground information that we can then try to combine with the satellite information to come up at least with rough estimates. We'll always have problems at the single house level, but to understand what the main typology in a certain quarter of a city is, I think that is something that we should aim for in the future.
If there's time, can I just jump in with a comment?
Please. I
think that's
there's
where
other sessions, so we can stay a few minutes if you want.
Oh, okay. Right. I think that's where Human Planet Initiative and some of these other efforts are really valuable, because you're talking about the crowdsourcing community. We're talking, there's all the engineering communities that deal with the specific details about built infrastructure. There's people who do household surveys and the censuses and surveys, which have really valuable data, relevant to vulnerability and resilience. So getting all these people to work together and then quickly scaling up is non-trivial. And I think one thing we found is, for example, being able to process sub-meter scale remote sensing data for the globe. There's only a small number of groups that have that capacity. Some of them are in the private sector. And, we've been working for quite a few years with Facebook, and they just have computing facilities that I can't possibly get through normal research channels. And there's lots of these ways in which we can collaborate. So we have been working with machine learning tools to extract building characteristics from, not just Earth observation, but, Google Street Map type imagery. We've been looking at extracting data from OpenStreetMap and doing comparisons. And, there's lots of local case studies, but how do you scale that up to the globe in a reasonable amount of time is really a big challenge. But that's where I think GEO and others can play a big role.
Definitely. Thanks, Bob. Last question, maybe to the audience. Do you have other ideas on how to combine your data with Human Planet data, or not? Some people.
Thomas,
Yes, David.
Can you hear me okay?
Yes.
Okay, excellent. Maybe just a comment for general awareness. Hi all, Dave Borges, NASA Applied Sciences Disaster Risk Program. Currently serving as one of the co-chairs of the GEO Disaster Risk Reduction Working Group. I just wanted to make a comment that among the many deliverables right now, the GEO-DRR working group is actually working with the climate change as well as capacity development working groups, and we've crafted a survey that we're actually going to be rolling out and meeting with all GEO work program activity leads, hopefully over the coming months. I know the summer timeframe will prove challenging for that. But the bottom line is, that, at least from our DRR perspective, is we want the output of this to be a comprehensive and authoritative subset of the entire GEO work program that for each of those efforts, but for instance, is focused at. So what GEO work program activities focus on disaster risk reduction and the Sendai framework global engagement priority specifically. Building off of that, the GEO-DRR working group is also simultaneously working directly with UNDRR as well as ESRI to build out an Earth observations risk toolkit that with the intent that it would be hopefully owned by UNDRR themselves, but informed by the expert community across GEO on disaster risk reduction. And so I really, was very excited to see Danielle's slides. He had two or three slides to this topic, specifically highlighting, how HPI can serve in that role of vulnerability, and noting that risk is that, the trifecta of vulnerability, exposure, and hazards. And we're really hoping that this GEO risk toolkit can serve, as a coordinated approach across GEO to integrate more, traditional hazards focused efforts with ones exactly like this. So I just wanted to make everybody aware of that, and look forward to following up offline with more. Thank you.
Thank you, David. Yeah, I think really what I can only recommend to you is to really have a look at the interaction that we had with UN Habitat on many fronts. On the one hand, for setting up the Earth Observation Toolkit, but also working with them together to have now the resilient urbanization as the fourth engagement priority. Because I think that this is really crucial that we work at an early stage with the UN agencies, in your case, UNDRR, together to develop something and not think that we know what they need and provide it to them. So I think this co-design that was taking place with UN Habitat proved to be quite successful. Daniele.
Just a quick comment to David. Actually, I'm part of the disaster risk working group of GEO. I'm in subgroup 3, and so we can be in touch through that.
Thank you.
Excellent. Thank you, Daniel. I will be in touch. Thank you.
Good. So last chance for questions, because otherwise I think we can wind down this session. I hope we could present some interesting overviews of the different data sets and application examples to you on the Human Planet Initiative. And if also later on questions pop up, I hope that you will find us and get back to us with additional questions. With that, I would like to thank all the presenters for joining, and also you again to come and listen to our session, and hope to see you for the next symposium, then also again physically, because then we could now move out and have a chat outside the meeting room. So that I would stop and wish you a nice evening, a good day, wherever you are.